Okay, so lesson 3.5, solving problems involving quadratic functions. So we're doing more word problems today. So we'll see that we have 1, 2, 3 examples. So it's not going to be a super long lesson, but we'll be able to see different types of quadratic word problems and how to go about solving them. So let's get right into it. Example 1. Sally is standing on the top of a river slope and throws a ball. The height of the ball at a given time is multiplied by the function h of t, where h of t is the height in meters and time in seconds. When will the ball be 10 meters above the ground? Okay, so let's get a picture of what's happening, because a picture is worth 1,000 words. So we have Sally, she's standing on a river slope, so like this. She throws a ball, all right, so she throws a ball, this is her, throws a ball in the air, and then when will the ball hit the meters above the ground? Okay, so imagine it's a river, so river being blue. So when will the ball be 10 meters above the ground? So if we look at this last part here, when, well, that's asking for a time value, right? So the big picture of this problem is saying, well, it's looking for time, t. And it's giving us the value that we're supposed to evaluate t at, right here. So this is saying, what is t when h of t equals 10? And so h of t being 10, well, let's say this is 10 meters above the ground, 10 meters. What I'm looking for here, if this is time being 0, and this axis is the time, so time goes this direction, right? Well, what is the time value here, such that when she throws the ball, it is 10 meters above the ground? So you can kind of see it has the shape of a parabola. So we are solving this quadratic. We are taking the equation that it gave us, which is h of t equals minus 5t squared minus 10t plus 250, and we are setting h of t to be 10 from right here. So we have 10 equals minus 5t squared minus 10t plus 250. Okay, and you'll start to see a pattern here, right? Whenever we do these kind of like height problems, when you're throwing a ball or something, we're going to ask you for a time when it's at a certain height. But the trick is we can't solve this quadratic when this has a 10 here. We need it to be a 0. So let's bring this 10 over to the other side. So that means we are taking away 10 from both sides, right? So you'll have 0 now, that's the goal, is minus 5t squared minus 10t. And then 250 take away 10 is plus 240. Okay, so now we're solving this quadratic. Well, see how you have a minus 5, a minus 10, and a plus 240? All of those are divisible by 5, so we can factor out a 5. So if we factor out a 5 from each term, 0 is minus 5t squared plus 2t. Well, 240 take away 5, my mental math is not great right now, 48. So that'd be minus 48. Okay, now we have a simple trinomial here. So let's factor that. That becomes 0 is equal to minus 5. Minus 5 is our a value. And our simple trinomial is we need two numbers that multiply to give minus 48 and add up to give us plus 2. So what are the multiples of 48? So that's an 8. 48's multiples are 1, 48, 2, 24. What would that be? 3, let's see, 48 divided by 3. Yep, so say 3 and 16. 4 and 12. What do we got? 6 and 8. And yeah, that combination will work. So if I make this minus 6 and plus 8, well, then you'll have minus 6 and 8 multiplied to give you negative 48, and minus 6 plus 8 will give you that 2. So then factoring the simple trinomial is t plus 8, and then t minus 6. And again, we're solving, so we actually need to find the values of t that make this 0. So take this bracket, t plus 8, set it to 0, and solve. So you'd find t being minus 8, and in the context of this problem, t is measured in seconds. And then over here, you get t minus 6 equals 0. Bring the 6 over. T equals 6 seconds. Okay, so what we have just found is that the ball will be at 10 meters when time is either 6 seconds or negative 8 seconds. But the problem is negative 8 seconds doesn't make any sense. Time can't be negative. Can't be negative. So then this is really your only solution. So therefore, go back to the problem. When will the ball be 10 meters above the ground? Well, that means right here, this is at 6 seconds. So the ball is 10 meters above the ground at 6 seconds. And visually, what does this negative 8 mean? It's not that it's not a root. It just means, see how we start here at 0? And we started our parabola here? If you were to continue this parabola going down here, notice that like we're now in the negative time. This is negative time. And right there would be minus 8. That's the point where it would strike the ground. Oh, sorry, actually it'd be at the 10 meters, but same concept. It'd be right here. 10 meters above the ground at minus 8, right? But you're in the negative time space, which isn't a thing. Okay. Example 2. A software company models its profit with the function p of x, where x is the number of games in hundreds. All right, so we're getting into this whole like number of games in hundreds. So remember, in order to actually get the number of games, it's going to be x times 100, right? Because you're measuring in hundreds. And then the company sells p of x is profited thousands of dollars. So eventually you'll get a profit value, and to get the actual real profit, you'd have to multiply this by 1,000. So determine the maximum profit the company can earn. Well, maximum, again, keyword, maximum. Well, this is a quadratic. So here we are looking for the vertex. And specifically, it's asking for the profit, not when, or the number of, number of games. It's asking for the maximum profit. Well, profit is essentially the y value, or in this case, it is the k value of our vertex, of the vertex. So find your vertex. So how do we do that? Well, we kind of have to take this standard form equation, this p of x equals, or I should work upwards more. P of x equals minus x squared plus 13x minus 36. This is in standard form here. So big picture, what do we need to do? We need to first get this into factored. Then we need to find the h value. Then sub h to find k. And the reason you do this is because remember the h value is the halfway point between your x-intercepts. So take p of x and factor it. So start by taking out the negative that you see in front here. Always take that negative out. So you'll get equals minus x squared minus 13x plus 36. Okay, so look, this is now a simple trinomial with a 1 here in front. So can we factor this? We need two numbers that multiply to 36 and add up to 13. So we have, in this case, and add up to, negative 13. So this will be 36 and negative 13. And remember, this is positive. So in this case, the multiples that would work would be minus 9 and minus 4. Minus 9 and minus 4. So factoring this, because it's simple, you can just rewrite your factors. So that'd be x minus 9, x minus 4. Okay, so that means you have your two zeros here when x minus 9 equals 0, or when x is 9. And then you have your other one, x minus 4, when that is 0. So that would be at 4. So remember, big picture, why did we find those? Because we need to find the h value. So now take these values here. So this was step 1. Step 2, find the h. H is equal to x1 plus x2 all over 2. So in this case, it's 9 plus 4 over 2. That would be 13 over 2, which is the same as 6.5. So that's not going to be a nice number, so we'll probably need to use our calculator to solve for the k value. So then part 3, you're solving the profit at the value of 6.5. This is our h. H equals 6.5. And you will get, this will solve, you will find your k value, right? That will be the maximum profit. This right here represents the max profit. All right, so let's solve. We are solving for p at 6.5. So we write p at 6.5, and you just substitute into your equation. You can substitute it in either the factored equation or the standard form equation. It doesn't matter which one, you'll get the same answer regardless. So just because I've never done this before, let me just show you substituting in factored. So if our factor form equation is minus 6.5 take away 9, 6.5 take away 4, so you get minus, and that first bracket, 6.5 take away 9, that'd be minus 2.5. 6.5 take away 4 would be positive 2.5. So because we're multiplying this negative with this negative, that'd become a positive times this right here. You know our final answer is going to be positive. But so what is 2.5 times 2.5? That would be 6.25. So our maximum profit, and keep in mind that 6.25 is measuring in thousands. So we need to take this and multiply this by 1,000, or essentially shift the decimal place 3. So therefore, and actually I'll do the math. So that would be 6,250. So therefore, the max profit, and this is dollars, profit is 6,250. Okay. Well, how many games must the company sell to be profitable? So in this case right here, to be profitable, essentially what it's asking for is, when is the break-even point? When is break-even? And remember, break-even is when the profit is 0. So if we take our p of x equation and we set it equal to 0, so our p of x equation, and we set it equal to 0, and solve for x, that would be how many games would be 0. So take your p of x equation, and I know we've already factored it, but actually we're going to factor this one. So we have the p of x equals, and actually we already did our factored. It's right here. This is our factored right here. So we'll just write that. Minus x minus 9, x minus 4. Okay, so you're looking for when this is 0. 0 is minus x minus 9, x minus 4. Well, there's 2 points. There is a point when x minus 9 equals 0, so when x is 9, and then right here. So it's kind of a repeat of the previous question. we had to solve these values. So what these mean, and again, these are x measures the number of games. X is the number of games in hundreds. So multiply these by 100. That means you'll have 2 break-even points. And so what that means is you're gonna be break-even. Let's get a visual. When the x value here is at 4 and 9, and we know this is an opening down parabola because here a is negative. So generally speaking, our parabola looks like this, where those are our break-even points, our zeros. So if you're measuring profit, if this line represents your break-even, and you're measuring profit, and here is the negative y-axis, well, all of this portion, when you're less than 4 games, you're negative profit. When you're greater than 9 games, you're also negative profit. So you're in profit between here and here. So therefore, we are in profit. Therefore, we are profitable when we sell. And again, take this, multiply by 100. So this is 900 and 400. So when we sell 400 to 900 games, we'll be profitable. If we start selling more than 900 games, I don't know what's wrong with our business. For some reason, we don't become profitable anymore. All right, so it's a bad thing to be too good. So that's what that means, okay? So a picture's worth 1,000 words. Last example. Example 3. Population type of question. The population of an Ontario city is modeled by P of T, where P of T is the population in thousands and T is the time in years. Note T equals 0 corresponds to year 2000. Okay, so let's talk about this because this is something we've never seen before. T equals 0 is year 2000. So if we solve this problem here, and let's say we got an answer like T equals 13 was a solution. Well, T equals 13 would actually be 13 years past year 2000. So in reality, your answer would be 2013, okay? So I'm just saying, if 13 was a solution, I've never solved this, so I actually don't know what it would be. So that's how you're going to report your answer, though. It's how many years past year 2000. So what was the population in 2000? Okay, so here it's saying it's giving you a time. It's saying in 2000. Well, year 2000 corresponds to when T is 0, right? Given right here. So we are given our P of T equation, and you're just substituting in 0 for T. So you have your P of T equation, which is 0.5 T squared, so 0 squared, plus 10 T, so 0, plus 300. So this goes to 0, this goes to 0, so you're just left with your C value, your y-intercept, your initial value, so 300. But again, it's measuring in thousands, so then you need to multiply this by 1,000. So the initial population is, therefore, 300,000 initially. What will the population be in 2008? Okay, so what is this giving us? Well, we are again given a T value of 2008 minus 2000, because we're actually starting at 2000. So our T value in this problem is 8. It's saying, what will the population be when T is 8? So population when T is 8 in this case now. So we have 0.5, 8 squared, plus 10 times 8, plus 300. So take out your calculator, all right? So 0.5 times 8 squared. So that would be 32 plus 80 plus 300. So then we get 412. I should double check my mental math is right. 450 plus 80, yeah, 412. But again, measuring in thousands times 1,000. So in 2008, so therefore, in 2008, the population is 412,000. When is the population expected to be 492,000? Okay, so in this case, when? Now in this one, we're looking for a t-value, but it's giving us a population. It's giving us p of t equals, and in this case, we need to take this 492 because the value we put in is 1,000 less, right? So it's almost like it's given us this math right here. So we just need to undo that multiplying by 1,000. So we are going to substitute the value 492. So we're looking for a t-value when our population, when p of t, which is 0.5 t squared plus 10t plus 300, when this whole thing equals 492. So 492 equals 0.5 t squared plus 10t plus 300. Okay, what do you think you're doing? All right? We're looking for this unknown, this t value. That's our unknown. And in the context of quadratics, when you're looking for the variable that has a squared on it, well, you got to factor this, okay? Factor it. So bring the 492 over to the other side. So that would be 0 equals 0.5 t squared plus 10t, sorry, that's a t, plus 300 minus 492. So 0 equals 0.5 t squared plus 10t, and then 300 minus 492 is minus 192. Okay, well, I don't think we're going to be dealing with nice numbers because, well, even if we are dealing with nice numbers, the fact that this is such a big number right here, right, that's going to make our life really difficult if we're trying to factor this. So let's just use the quadratic equation, make our life easy. So the quadratic equation is, and it's set to the variable t, is t equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And this 0.5 is your a, this plus 10 is your b, and this minus 192 is your c. So substitute all your values in. You're going to get t is negative b, so then in this case it's negative 10, plus or minus, well, 10 squared, minus 4 times a, 0.5, times c, minus, 192. All over 2 times a. Okay, so bring out your calculator. All right, so t, negative 10, plus or minus, let's clean up that square root. So that would be 100 minus 4 times 0.5 times 192 is minus, and because a negative and a negative, careful here, that would end up becoming a positive 384. So I don't need such a big square root. All over 1. 2 times 0.5 is 1. So then 100. So then you get t equals negative 10 plus 100 plus 384 is 484 all over 1. So we don't need that 1 anymore. We can actually just write it like that. So you'll have two values. You'll have the square root when it's negative and positive. So you have t minus 10 being plus the square root of 484, and we'll evaluate that in a second. And then you have your other value, your other possible solution, which is -10 minus that square root of 484. So let's evaluate what that square root of 484 is. So this would be t equals square root of 484 is 22. So that's actually a nice number. So -10 plus 22. And this is t equals -10 minus 22. So you have over here, this is minus 32. And this is t equals plus minus 12. Okay, well, what do these values mean? These are years. Years. So you actually have two valid solutions. I know here your initial thinking, and it's good thinking, that this negative doesn't apply because time can't be negative. But in this case, we're not actually starting at 0. In this one right here, this is saying if t equals 0 is corresponding to the year 2000, that means when t is minus 32, that is year 2000, 32 years earlier. So 32 years earlier is 68. 1968 would be when the population was, whatever this was, 492,000. And then this one right here is 2000 plus 12. So that would correspond to 2012. So therefore, there's two solutions. So therefore, the population is 492,000 in year 2012, and it was 492,000 in 1968. Okay, so there was actually two valid solutions here. So again, application questions, always think about what your variables you're solving for actually mean. All right, and that's it for now.